Welcome to 6.09. We're going to be working on writing sinusoidal functions if we are given a graph of the function. So this goes hand in hand with what we've been working on, and so it's probably a good idea to start by practicing some of the techniques that we've been using thus far. I want us to just get in writing, maybe once more, if you already have it in writing, just take a look and make sure you got everything correct. The method by which we discovered it is most efficient to graph our functions. And of course, you can create a table and kind of struggle through it sometimes in that way, but we want to have something that's kind of a little more efficient. And so here I have just a reminder of the different transformations that the parameters key us into, and that's going to be our initial step. Before we do anything, we want to just look at our function and figure out what are the transformations that occurred to the parent function to make this one happen. Look at the a, b, h, and k parameters and decide, did it get stretched out? Was it compressed? Was it, instead of being compressed, was the slinky kind of released? Was there a translation to the left or the right, a phase shift? Was there a translation up or down? What does that mean about my midline? And use that to just, in our heads, have a picture of what it should look like. Once you have this picture, we can now go into kind of working through it. So using our amplitude and our midline, we can determine the max and minimum values, right? Your amplitude is the distance that the maximum and minimums are away from the midline. So using your midline, you find your max and your min values. One more thing that I will add to this is that it's usually a good idea to sketch a quick dotted line through our midline. That kind of gives you just sort of a visual anchor that can be really helpful. So I might add that to step one. Now in step two, we're going to use the phase shift, which is the left or right horizontal translation, to plot an initial point. And here's what I mean by that. Cosine of x, when they're the parent function, its y-intercept is at 1, which is its maximum value. Sine, without a phase shift, sine of x, the parent function, has a y-intercept at 0, which is the midline. And so if you think about this, this is in almost all cases, unless you have a, which is a negative value, in which case it'll be reflected, so that cosine has a y-intercept at a minimum. That's the only difference here. You can use this fact to plot an initial point. So if you have a phase shift of, say, pi over 2, you know that this y-intercept, which was normally at a maximum, has now shifted pi over 2 units to the right. And that can be very, very helpful in just getting a basic idea of sort of a starting point for our function. Then finally, we're going to plot a max or a min and use the period to complete. So this is the big step. We're going to plot a maximum or a minimum value, and then since we know the period, we can compute the period using the b value, we can just then find the next maximum or the next minimum. Now if we have two maximum points, we know halfway in between them, based on our unit circle, halfway in between the maximum points, there must be a minimum point. Halfway in between a max and a min, it must hit the midline. And so using that, we can sketch our graph going on in either direction. And once we have it sketched out, we want to check that our graph makes sense with step 0, meaning go back to your transformations, your a, b, h, and k values, look at your period, look at your translations, your amplitude, and make sure that everything makes sense. All right, so now let's go ahead and get a little more practice with this before we move on to a slightly new but very similar topic. So go ahead, we worked a little bit on this in class, and what you want to do is complete this now on your own. So graph this function and make sure that you indicate the amplitude, period, midline, and phase shift for your function. All right, so I hope that went well. I'm going to kind of step you through this piece by piece. So first, I just looked at this and noticed that there are some transformations. First off, we have a sine function, and there is an amplitude of 3, meaning that the max and mins have been stretched. And there's a phase shift of pi over 4 units to the right, so everything should shift pi over 4 units to the right. So I have a basic idea of what that looks like. Now I can begin to actually put pencil to paper. So the amplitude is 3 and my midline is 0. I'll just sketch the midline briefly. And now I know that my maximum value is going to be 3 and my minimum value is going to be -3. Keeping this in mind, I now want to look at my phase shift to plot my original or my initial point. So the phase shift is pi over 4 units to the right. And so knowing that we're dealing with a sine function, if there was no phase shift, the sine function always has a y-intercept at the midline. But now this point that intersects the midline is going to shift to the right pi over 4 units. So what was at the midline at the y-intercept, right, is now shifted pi over 4 units to the right and occurs when x is pi over 4 instead of when x was 0. So I can plot this initial point on my midline at pi over 4. And now I want to plot a max or a min. We'll just go ahead and plot a max. We know that sine is at its maximum value when the argument is pi over 2. In other words, when we have sine of pi over 2. So we want to find the x value that will make this argument pi over 2. In other words, we want x minus pi over 4 to equal pi over 2. What will that x value have to be? And you can solve this by adding pi over 4 to both sides, and you'll get that x is 3 pi over 4. So we know that we're going to have a maximum value at 3 pi over 4, which is at this x value right here. So its maximum is 3. We'll have a maximum right here. And now we can plot where the next max is going to occur. So what is the period? Well, we know that the b value is 1, so my period is 2 pi, and so I'll have to move 2 pi to the right, or 2 pi to the left to get the next maximum. If we move 2 pi to the right, we'll be off the screen. We'll be at 2 3/4 pi, might be over here, and so we can move 2 pi to the left. So notice that 2 pi to the left will be 3/4 pi back to the y-axis, because this is 3/4 pi, and then another 1 1/4 pi to get to 2 pi away, right? Because 1 1/4 plus 3/4 will be a total of 2. So 1 1/4, here's 1 pi, and then 1/4 of pi will be right over here. So my other maximum is going to be at this point right here. And then halfway in between, there will be a minimum value. So see if you can find out where that is and then complete your function. So halfway in between, notice that the distance between these two is 2 pi. So halfway will be pi. And so if you're at 3/4 pi, then pi away will be 3/4, and then another 1/4 will be right here. And so your minimum value, which is at -3, will be right there. So now we have a minimum. We could plot another minimum using the period. Since we have 2 pi as our period, we'll move 2 pi to the right. This back to the y-axis is 1/4 of pi, and so then I'll need to move 1 3/4. And so this is 2, and 1 3/4 will be right there. So here we have another minimum. We have halfway in between the minimum and the maximum will be at the midline. So we can plot those points as well, and that'll allow us to sketch our graph. Alright, so here we have our completed graph. Notice the period is correct, the midline is correct, we have an amplitude of 3 stretched, and that there is a phase shift of pi over 4. So this point that would normally be the y-intercept of our sine function, since there is a phase shift, has now shifted pi over 4 units to the right. Okay? So let's go ahead and let's try a couple more. You can try these on your own, and then we'll just talk briefly about them. Take a look at a couple more. Notice that I have 2 different graphs here, and so you'll want to use this counting scale for this function here, and you'll see why, and then this graph here is set up for g of x. So go ahead and give these a try. Really persevere here. If you get stuck, keep going, try and figure it out, and have a full sketch done before we go over them, because I'm going to go over them rather quickly. Alright, so first I've visualized the types of transformations that I'm going to have. I'm going to have a translation upwards of 1 unit. There's no phase shift, but I do have a change in my period. The b value is greater than 1, so I know that it's going to cut my period down. It's going to compress it together. And then I have a negative out front, which is going to reflect my function over the midline and also stretch the function because of the amplitude change. So using the amplitude in the midline, I'm going to get an idea of the limits of my function. The maximum value it could be is 3.5, and the minimum is negative 1.5. My midline is y equals 1. So I'm going to go ahead and just sketch that out. And so now I can go ahead and think about where is my initial point going to be. And the way to think about this is to consider that it's a sine function with no phase shift. So if you look at your unit circle, since there's no phase shift, sine of 0, your initial point, your y-intercept, is going to be at 0, right? And so that means that sine, as we talked about, its y-intercept is on the midline. Since there's no phase shift, it's going to stay on the midline. So the y-intercept, and we can plot this point, is going to be right there. All right, so now let's move on and let's find a maximum or a minimum point, that's that last step, and use the period to plot further maximum or minimum points. So the first thing that we want to do is think about where sine is at its maximum value. Sine is at its maximum value when the argument is pi over 2. So notice that to make the argument pi over 2, to make pi times x pi over 2, x will need to be 1/2. And what I mean by that is to make pi times x equal to pi over 2, right? This x value needs to be 1/2. And the way I could find that out is by solving for x by multiplying by 1 over pi on both sides, and getting that x must be equal to, pi over pi is 1/2. So the x value that will make sine 1 is 1/2. So if I'm looking at my xy axis, here's 1/2. Now, this would be where sine is at its maximum, meaning that sine will be 1. But since I've reflected, it's not going to be at its maximum. In fact, it's going to be at the minimum, because 1 times negative 2.5 is negative 2.5, plus 1 is negative 1/2. So I'm actually going to be at negative 1/2, and that's going to be a minimum at the x value of 1/2. Okay? So that is a minimum value. Now the period is 2 pi over pi, because pi is the b value. 2 pi over pi is 2. So the next minimum is going to occur 2 units later. This is 1/2. 2.5 later, 2 later will be at 2.5. Halfway in between these 2 points, I'm going to have a maximum value of 3.5. Notice the way that I figured that out is that this is a distance of 2. So halfway will be a distance of 1. If this is 1/2, then I'm at 1.5 here, and that's my maximum. Halfway between a minimum and a maximum, I will intersect the midline. And so I can use this to complete the plot of my graph. And there it is. Notice that I'm not the best artist in the world, but this seems to make sense. I have a reflection, right? So sine normally starts at the midline and increases, but now it's starting at the midline and decreasing. I have a midline of 1. The period is 2. It's compressed slightly. And the reason it's compressed is, imagine what 2 pi is. 2 pi is approximately 6.28. So normally the period would actually be 6.28, or much longer than we've actually got here in our positive x direction. All right, now go ahead and complete this last one. I'm just going to post the final solution so that you can compare it, and then we're going to move on to something slightly different. All right, so there you have it. The one tricky piece here is that the period is 2, but we're counting by pi over 2's. Notice pi over 2 is a little more than 1/2. So this distance, this is my initial point, which happens to be a maximum. And when I move 2 units to the right, that's going to be a little more than pi over 2. It's going to be about this much. I approximated it, and so then I'm just going to approximate to continue on, and the minimum is going to be halfway in between. Okay, so what I want us to do is kind of pick apart sine and cosine and really dig down into the key characteristics that are unique to both sine and cosine. So looking here at the graph of the parent functions, cosine is in blue and sine of x is in red, try and write down some of the key characteristics that are unique to both sine of x and cosine of x. All right, let's start with cosine of x. If we're looking at cosine, notice that its y-intercept is at 1, which is its maximum value. In other words, if we actually are starting right here, where we normally start if there's no phase shift, then our cosine value is going to be at its maximum. So that is the first key characteristic. And notice that cosine, as we then start to rotate in a counterclockwise fashion, that cosine will then start to decrease. The x-coordinate decreases, right? Notice that the value of cosine is decreasing. And so that is the first key characteristic. Okay, so cosine with no phase shift, right, the cosine function, will have a y-intercept at the max, and then it will decrease in value. Similarly, if we look at the sine function, we notice that sine of 0 is at the midline, 0, and then increases. The y-coordinate increases. And so similarly, the y-intercept of a sine function with no phase shift is at the midline and will then increase. So now I want us to look a little deeper at the relationship between the two. Notice that the sine function seems to match up perfectly with the cosine function, right? So here's the sine function, and if we just were able to shove the cosine function over to the right, it seems like it would match up perfectly. And we discussed this earlier on, where we said if you phase shift, if you translate your cosine function pi over 2 units to the right, it will be exactly the same as the sine function. In other words, sine of x is equal to cosine of x minus pi over 2. Thinking about this, looking at your unit circle, if we were to plug in 0 for x, now we'd have cosine of negative pi over 2. Negative pi over 2 is down here. The cosine of that is 0. Sine of 0 is 0. And if I were to keep rotating in this direction, cosine starting down here and sine starting up here, we notice that the values match up perfectly. Cosine is 1/2, sine is 1/2. Cosine is pi over root 2 over 2, sine is root 2 over 2. And so it would match up perfectly as long as we phase shifted cosine by pi over 2 units to the right. And notice that this also allows us, so if I had a cosine function and I subtract pi over 2 from the x value, in other words, I institute a phase shift of pi over 2 to the right, it will now be the same as a cosine function with no phase shift. I'm going to say that one more time. If I have a cosine function and I phase shift it pi over 2 units to the right, it is now a sine function without the phase shift. Similarly, if I have a sine function, this red function, and I were to phase shift it to the left pi over 2 units, it would be a cosine function with no phase shift. So if I have a sine function and I phase shift it to the left, meaning the h value is negative by pi over 2 units, it will be a cosine function with no phase shift. And so this will allow you to translate between sine and cosine functions with ease. Okay? So keeping this in mind, we'll now be able to do some more complex problems. So now we want to take a look at a graph and write the function which it represents. So pause the video at this point and try this completely on your own. You can do it at this point. So do not give up easily. All right, so I wrote out the general form of a sinusoidal function. And what you'll notice is that there are two versions, but the only difference between them is whether it's a sine or a cosine function. And armed with the key characteristic of sine and cosine, we're going to be able to pick whether we want to use a sine or a cosine function very easily. Okay? So what we need to do in order to create this function is determine the a values, b values, h, and k values. In other words, the parameters that would create this function here. So with that in mind, you can do this. I want you to pick apart this function, determine the a, b, h, and k parameters, and then choose whether you want this to be sine or cosine, and write out your function. So what we want to do is determine these parameters in a way that makes the most sense. So just like we've talked about previously, the amplitude and the midline, the a and k parameters are linked, right? If we can find the distance between the min and the max, Halfway in between is going to be the midline. And so noticing here that the max is at 3, the min is at -1, that is a total distance of 4. So halfway in between is going to be 2. Notice what I did is I counted the total distance and cut it in half, right? So halfway in between is at y equals 1, and that means that my amplitude is going to be 2 because it'll take 2 to get to the max and 2 to get to the min. And so my midline is going to be 1, so k is equal to 1, and my amplitude is going to be 2. Now let's look at the period. And the reason the period is going to be the next easiest is that when we work with the phase shift, we'll also have to think about whether it's sine or cosine, and so we'll put that off until the end. Looking at the period, notice the period is the distance between consecutive mins or maxes. Well, looking at the max, we only have one max on the screen, so let's look at the minimum values. The distance between these is 4 pi, right? Because this is -2 pi and this is +2, so that total distance is 4 pi. And so remember, our period is 2 pi divided by b. And we know that this is equal to 4 pi. So what is my b value? Well, let's solve for b. Go ahead and pause the video, try that on your own. To solve for b, we'll multiply by b on both sides and divide by 4 pi on both sides. And so what I end up with, I have 4 pi over 4 pi here, which is 1, so I'm left with b. Over here I have b over b, which is 1, and I'm left with 2 pi over 4 pi, and pi over pi is 1, 2 over 4 is 1/2, so my b value is 1/2. Okay, so b is equal to 1/2. And now if we take a look at our function, the only thing we have left to decide is what is the phase shift, and should I use sine or cosine? So think back to that key characteristic of sine and cosine. Is either one of those apparent here? Remember that sine, if there's no phase shift, it will have a y-intercept at the midline. Does this have a y-intercept at the midline? No. Its y-intercept is at the maximum value, and that is exactly the characteristic that cosine has. Its y-intercept is at the maximum value. So this fits a cosine function with no phase shift perfectly because it has a y-intercept at the max, and we know that a cosine function with no phase shift will have a y-intercept at the max. So we will choose a cosine function where the phase shift, there is none. So now we can write our function, f of x is equal to, our a value is 2, we're going to use cosine, our b value is 1/2, and we have no h value, no phase shift, so 1/2 x plus, and our k value here, we had a k value of 1. So this is our function. Okay? So go ahead and maybe kind of go over the steps that we went through here and see if you can kind of come up with the strategy that you're going to want to use to determine the exact function that will model a graph that you're given. And then we're going to go ahead and try a couple more, and we'll talk about those in class tomorrow. So with this graph, I want you to write both a sine and cosine function that could represent the graph below. So go through it, just kind of following the same steps that we did previously with what makes sense for writing a cosine or sine function. Choose whichever one makes the most sense. So maybe you decide sine or cosine, whichever one makes the most sense. Write that function, and then think about how you could then write another function where you use the opposite trigonometric value. So either sine and then write cosine, or use a cosine and then go to sine. We'll talk about this tomorrow.